example. Okay, so we've got a UFO that's currently 500 meters away from the surface of the Earth. So here's the Earth, and here's our little UFO hovering in space. Okay, and it's currently 500 meters above the Earth. So it's sitting 500 meters above the Earth. And at this moment, it has a velocity of 50 meters per second. So it's not really sitting there. We take a snapshot, and at that first snapshot, it's 500 meters away from the surface of the Earth. And in that snapshot, it currently has a velocity of 50 meters per second equals its velocity, and it also has a constant acceleration of 100 meters per second is equal to its acceleration. So what will be the velocity of the UFO in 10 seconds? So if we want to know the velocity of the UFO, acceleration equals change in velocity over time. We know that the acceleration is 100, change in velocity divided by, we're looking 10 seconds later, so we've got 1,000 meters per second is equal to the change in velocity. So our final velocity is going to be our initial velocity, should mark that, V initial. V final is going to be those two added together, so we've got 1,050 meters per second. So it's really moving pretty fast at the end there. If we want to know what its location is, how far is the UFO from the surface of the Earth in 10 seconds, well, we need to set up that same equation we used before, distance according to time, 1/2 acceleration, if it's a constant acceleration, times the time squared that we're looking at, plus the initial velocity it had times time, plus its initial starting location. So we plug those in. We're looking for its distance at 10 seconds is equal to 1/2. What's the acceleration it has? Interesting point to look at. Is gravity affecting this? Yes, gravity is affecting this, but we don't need to subtract for it because we were told in the problem that it had a constant acceleration of 100 meters per second away from the Earth. So whoever gave us the problem, however we got this information, we know the acceleration. There's some forces involved, gravity is pulling, and it's probably got thrusters or something causing it to move away from the Earth, but we don't have to worry about that because we were told its acceleration is precisely, so we're good with that. So 100, and it's positive because it's moving up, times the time squared. Oh, we do know the time. Plug that in. 10 squared plus what's initial velocity? 50 times the time. 10 plus its initial location, 500. Great. Start plugging things in. 50 times 100. 1/2 times 100 becomes 50. 10 squared becomes 100 plus 500 plus 500. We get 50 times 100 becomes 5,000, plus 500 becomes 1,000. So we get, in the end, it is 6,000 meters above the Earth. Great. All right, hope you enjoyed that, hope it made sense, and next time we'll look at how multidimensional kinematics works when we're looking at more than one dimension. All right, see you at Educator.com later.